Hello there, welcome back to the Engine series. Today we're going to be talking about entities, what they are, and how they fit into the Entity Component System, or ECS, architecture. Now before we get into the code, we might need to answer a few questions, like what is an entity in this example? Well, for us, an entity is just a number. That's it. The components that an entity has access to are stored separately. So all of the data for an entity is not stored on the entity itself. There's not going to be a struct entity with a whole bunch of different component types on there, because the only way of making different types of entities, well, not the only way, but it would be very difficult to make different types of entities and also be able to iterate over all of that data in a predictable way if you went with a different approach. And before we go any further, I just want to say this is probably an over-engineered solution for the game that we eventually will make. But I feel like the flexibility might come in handy later. I know that's a really controversial position. You know, if you program for flexibility that you don't know you're going to need, then you are essentially wasting your time. However, I did get a fair way into this project before I decided to start again from scratch. I got up to a point where I saw that maybe an entity component system for this project could work. So that's what we're going to do. We're going to give it a go, and maybe we'll have to change it later, but yeah, I guess we'll just see. Alright, here we are over in the trusty drawing application. Now I've just laid out this, what looks probably like an array, and that's because it is. So this is just going to be a little example that we're going to go over. So let's just imagine that this is our entities array. So this is the current entities in the game, and we're going to cut it off here and say there's only 4. So the whole array is 4 long, and we've got something in here, something in here, something in here, but then we've got nothing in here. Okay. So what happens when we want to add something in here? Well, we just add something. That's fine. So this becomes another entity. Okay, but now the entities array is full. So what happens when we want to add another thing? Well, actually, it's going to double the size of the array, and then it's going to stick it here, and then these are all going to be empty. So this process will work up to a maximum size of just over 4 billion. So we have about 4 billion entities to play with until we have to start recycling. But let's say we reach that limit. Okay, we've reached 4 billion, everything is full. Alright. Now there's something else that we do. When we don't want an entity to exist anymore, we call a function called retire, ECS entity retire. The name isn't important right now, but in any case, this is the function name, and let's say we want to put the this entity here, right? So we have a handle that we get when we grab an entity. So when we use the ECS entity source, then we actually get a handle, which has a type. It's called ECS underscore entity, and we'll just call this A. Okay, so we've got an entity here. It's called A. Now let's say A was in this slot. Now we retire A. So we'll just put it in here. And then this actually becomes empty. So that means that even though we have an array of 4 billion plus the max size of a 32-bit unsigned integer, we can actually, if we know that it's 4 billion plus, like the max size, we can then search through the array until we find an empty slot, and then we can return that as the new entity. So this is a way of recycling if we really need to. Like if you really push past that 4 billion, you can recycle, although it will be slower because you have to do a linear search. I imagine most of the time you're not going to hit that, but who knows? We might have to refactor it later. This is how it works for now. Now let's say you do that, another time here. Okay, but now this one's taken, and then the next time you have to search all the way down to here until you find this one. Okay, that's cool. What happens if you search the whole thing and you can't find any entities? Well, then the program exits. So that's sort of how the system works. And since entities are just numbers, you actually use the index of the array. So this is 0. This is, I don't need to draw arrows. This is 1, 2, 3, 4, 5, 6, 7, blah, 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 all the way up to 4 billion, whatever. Okay, and then when you retire an entity, let's say this one, this becomes free, and then this doesn't change, so it still stays as 5. And then the next entity that's created after this whole thing is full is going to be number 5. It's not going to be number whatever this is plus 1, because that will not work. So yeah, that's kind of how it works. So what are the advantages of something like this? Well, one is it's very, very quick to add a new entity up to that 4 billion mark. It's just increasing a number by 1 and then returning that number, pretty much. Okay, it's got a relatively small footprint because this is just an array of unsigned integers. And it's pretty easy to use because you've just got 2 functions here, retire and source. That's all you really need to know from, externally. Now there's going to be more functions to do with adding components that we'll have a look at when we get to components. But this is pretty much it for now. Now what are some disadvantages? Well, the disadvantage is just because you have an entity ID doesn't mean you know anything about the entity. So you're going to have to query some system which is going to tell you, hey, does this entity have a transform component or a position component or a rotation or a velocity component or a physics component or a render component, whatever components you decide to make. You're going to have to go through a list of those components and check, oh, does this entity ID exist within this list? So that can be slow lookup because it's a linear operation. Now I have an idea about how to potentially speed that up using bit masking, so you can have a maximum of 32 types of components, and then if we need to optimize it later, we can look into something. Oh, I should say another advantage of this system is that, and this is more to do with components rather than entities, if you have all of your entities with all these different types of data on them, you're going to have to go through every entity and then check if they have a specific component and then operate on that component every frame. If you want to, let's say, move something down because of gravity, you're going to have to loop through all the entities that have a component type of, whatever, physics component, and then change the position or based on their velocity, based on the gravity, whatever. And you're going to have to do that for each entity, whether or not it has a physics component or not, unless you store the components separately, which is what we're doing. And you could do that with the other system, and the other system could have a pointer to all of its components. Like you could have an entity struct and then a pointer to different types of components could live on there. That could work. That's another way of doing it. But the idea is that you want to decouple or rather group the data. So in this version, all of the components of one type are going to be in one array. So every single physics component is just going to be in one long array, and you're just going to iterate over them and change them just based on what they are and what values they have. That should be pretty good. And let's have a look at the code. Okay, before we jump into the actual code, I just set up a little test here. Let me just explain what this is. So this is the entity index 0, 1, 2, 3, 4, 5, 6, 7. Now for this example, I've actually changed the unsigned integer maximum to 16. So instead of being 4 billion, it's 16. So as soon as we get to 16, that's the max amount of entities that we can have. Alright, so this is the ID, and then below it is whether it's taken or whether it's free. If it's taken, it has an X. If it's free, it has a green underscore. You can see all the free slots pretty easily. Alright, now on the left here, let's just go through this quickly. At the beginning, we just create 4 entities, A, B, C, and D, and they take up these 4 slots right here. And then we print the pool, which is this. Oh, I did this in a weird order. Sorry, one second. Okay, so I've just swapped these 2 lines around, the entity retire and the print the pool. So what we do is we make the 4 entities, and then we retire B, which is this one. So you can see in our first printout, we've made 4, but then there's an empty slot here now. Then we just source a new entity, and it doesn't go back to the first one. It actually just grabs the next one. And then it will just grab the next one as long as it can. which means if you retire a lot of entities, then this could actually end up being really large in memory, but it will still be much faster to get new entities. Now, there could be another version of this where instead of, as you can see here, we've added more and more entities until we fill this up, but instead of going back and grabbing this one, it actually doubles the array size and then gives us the next one, which is 8. Now, I don't know whether this is, or a different version where you go back is going to be more performant. We're going to have to test that later. Alright, so we just add more entities, more and more and more. You can see it filling up, filling up, filling up, filling up. And then finally we get to this slot here, which is, well, this all looks the same. But, so this is all full, and we're at the max uint because I changed it to 16. It's not 4 billion. And now, when we add another entity, it actually goes back and it grabs this empty slot and gives us that. And then we try to add one more and it says no entities available. So that's sort of a demonstration of what I was talking about. Alright, here we are looking at the code. Let's just make this a bit bigger. So, we've got one macro at the top here that is relevant, which is ECS entities initial. I'm thinking I might rename that. But this is the size of the array initially, the size of the entity array. So if you know that you're at least going to have, 500 or something entities at the beginning of the game, then you can set that to like 500. And then when you need more, it's going to double that and then double again and again and again, etc. Although I would suggest using a power of 2 because the way the code works, that will allow you to, actually, you can get to the max size anyway. Never mind, I fixed that. Alright, this uint max 16 is not relevant. This is just for testing. That was just setting our 4 billion value down to 16 so we could test it. Now we've got this type def here, unsigned int ECS entity. So every entity is just an unsigned integer, as I said. But the reason that I'm type defing this is so that it's very, very clear when a function returns ECS entity that you are working with an ECS entity. Because if you just type unsigned int, or if you just put unsigned int here, it's not really clear what the intent is. You could come back to this function later and be like, why is this returning an int? What isn't this got to do with entities? So this entity pool is actually the array, but it's called a pool, but it doesn't really follow the standard rules of an object pool. Entity next is just the next ID, so it starts at 0 and then it goes up by 1 until you get to the 4+ billion, and then it returns back to whatever the next available slot is. The length is just the length of this array, which we've defined here in this macro. So I've defined it as 8 initially. Alright, so this init function does need to be called, because we do need to initialize the entity pool. Right, so now we've got the entity source function. Alright, so at the top here we just declare an entity that we're going to return. I'm going to add a few more comments in here just to make it more clear. But yeah, this first one is just if the array is not full. We just return the next entity and then increment the entity next. Or rather, we assign entity to entity next, then increment it, and then we return it down here. And we also set the value to 1. I should probably mention that. That's pretty important. So all of the values that are unassigned, these are zeros. So that's how we can tell there's nothing in there. The x's are all 1s. So if there's a 1 in here, then we know that an entity exists. If there's a 0, then no entity exists. Alright, so this first else if just checks to see whether we have enough space to double the array. And if we do, we just double it, reallocate, and then set the length to the double of what it was, and reassign the entity pool to the new entity pool, just in case it failed, although really we don't need that because we always exit the program if it fails. But anyway, then we just do the entity equals entity next again, and increment the entity next. So the same as before. There's a little bit of repeated code in here, but that's fine. It's only a few lines. Now this one is in case we are about 2 billion of the way through, whatever the max unsigned 32-bit int is. So we're about there, and we want to double it, but actually we don't have enough space to double it because we've added a bit more or something like that. And in that case, we just fill it out to the rest of the 4 billion. So it's pretty much the same as up there. But this will max it out. And finally, if the size is maxed out, then we can go back through and look for an entity. If we don't find one, then there's no entities available and we exit the program. But if we do, then we just assign the entity as in these other ones, and we return that. And we also set the value to 1. So it's pretty straightforward. Now we've got this little print function. We don't really need to go over that. And the retire function right now is extremely simple. All we do is we get the unsigned ECS entity. Make sure, I mean, it should be unsigned anyway, but I just did this, I guess, out of habit. Now we want to grab the index and then just set it to 0. So as soon as it's set to 0, that entity is essentially destroyed. There's going to have to be extra systems built on top of this to make sure that when an entity is 0, it doesn't show up anymore, it doesn't render anymore, doesn't move anymore, it doesn't get updated anymore, stuff like that. And this little section here is going to be about going through all the components, figuring out which ones belong to this entity, and then kind of doing the same thing to them that we do to entities. So every component is going to be in a little array of its own, and then we're just going to set them to like available, not available, kind of. And then if they're available, we just assign an entity to that component. So they're going to work pretty similarly. Alright, that about wraps it up for this episode. I hope you enjoyed. I didn't do all the typing this time with you guys, so just let me know in the comments if you'd prefer for me to actually type it out, or if you don't mind going through like this, because I mean, obviously it's easier for me. I don't have to type the code twice. But you know, if it affects your ability to actually take in what I'm doing, then of course I'd rather type it out twice. So yeah, just let me know. Alright, if you enjoyed this video, make sure to leave a like, and if you like videos like this, make sure to subscribe down below. They come out every Sunday, and I have another general programming video every Wednesday, as long as sometimes some gaming videos. So thank you for watching, and catch you.